All right, so in this video, we're going to be graphing to find roots. So whenever you have a function that is a polynomial, this is going to be a quadratic polynomial because the highest exponent is going to be this 2 down here. What you can do is you can figure out where the graph is going to cross the x-axis, and these are called the zeros. And it's just going to be two numbers. In this case, they're going to be two numbers that are positive since they're on the positive side of the x-axis, and they're going to be x equals a and x equals b. So what that means is these are the places where the function is 0. The y value is going to be 0 there because that's where they cross the x-axis. So f of a is going to be equal to 0 and f of b is going to be equal to 0. So if you know the zeros where it crosses the x-axis, then you can list the factors of the polynomial. Now the factors of f of x are going to be x minus a and x minus b. So whatever number that you find, you're going to subtract it from x right here. And if you have both of those, at the very end, you can FOIL those to multiply them together to find the missing polynomial. But we're going to try that in reverse with this one. So what we want to do is we want to find the roots of this polynomial and we want to verify it by graphing. So the very first thing I'm going to start off by doing is by writing down the polynomial and setting it equal to 0, because we want to know where the y value is 0 or where it crosses the x-axis. That's going to give us our roots, whatever x is. So what I'm going to do with this one is I'm going to try factoring it. It looks like it can be factored because you need to find two numbers that multiply to 20 but add up to -9, and you can do that. The two numbers that multiply to 20 are going to be -4 and -5. Notice that they also add up to -9, so these two numbers are going to be able to factor this. So it's going to factor down as x minus 4 times x minus 5. I just put those two numbers on the inside of the factors. But notice everything is still set equal to 0, so I have to set this equal to 0 as well. Now that's going to set up two different equations because I'm going to set the factors equal to 0 now. So I'm going to have x minus 4 equals 0 and x minus 5 equals 0. So I just set what's inside the factors equal to 0, and now I have two equations that I can solve for x. On the left side, I can get rid of this -4 by adding 4 to both sides. That'll get rid of the -4 on this side, and then on the next side, 0 plus 4 is going to give me 4. Over here, I do the same thing. The only difference is I add 5 instead of 4. That'll get rid of the -5 on the left side. And I get 0 plus 5 equals 5. So those are going to be my roots. They're the numbers that x is going to be equal to. I take those two numbers and I put them inside of a solution set. So these are going to be my roots, also known as zeros, also known as x-intercepts. Now, what this means is when I evaluate this function at 4, I'm going to get 0. Also, if I evaluate the function at 5, I'm also going to get 0. That's what roots mean. That's the input where the output is 0. So that's where the equation is going to cross the x-axis. So let's go ahead and verify this by graphing. So what I want to do is head on over to Desmos and I go ahead and I graph this. So when I graph it, what I get is this red parabola, and what it does is it crosses the x-axis at +4 and +5. So that's a very quick way to verify what the roots are. You're going to graph the equation as a function and then see where the graph crosses the x-axis. And where it crosses, those are going to be your two roots. So that's verifying by graphing, figuring out roots of quadratic polynomials. There's a bunch of different factoring techniques that you can learn, and every single quadratic polynomial in existence, you can find the roots of it using the quadratic formula. And that's going to be on another video. So that's verifying by graphing, and I hope that helps.